Okay, so today in class you reviewed measuring in centimeters, which you're probably more familiar with, and inches. When measuring in centimeters, you can write answers as a decimal, since there are 10 millimeters in a centimeter. Therefore, any portion of a full centimeter is going to be a decimal. However, in inches, you have to write the answers to things measured in inches as a fraction out of 16, or 8, depending on which ruler you're using. So basically in a ruler, there's the centimeter side, and then there's the inches side. And then all I'm saying is that just depending on which kind of ruler you have, it's either going to go is 1 inch, or it's going to go 1, 2, 3, 4. Like this, to show all the little components of an inch, okay? So that's basically all you need to know about measuring in centimeters versus inches. But what you should be thinking now is, well, how does this transfer to algebra? Well, if you add together a line that measures 2.3 centimeters and a line that measures 3.2 centimeters, well, let's make this longer since it's 3.2 centimeters, okay? If you add them together, you get 5 centimeters, right? Well, what if you add an x into the equation in order to find the missing piece, okay? So let's say you know that this line over here equals 3.2 centimeters, and you know that the total line equals 5 centimeters, but you don't know what the other portion of the line equals, well, then you can just use algebra to find it out. So you can do plus x equals 5 centimeters, subtract 3.2 from each side, and you get x equals 2.3 centimeters, okay? So that's how we can use algebra to kind of find missing distances. But I want you to also think about finding distance graphically, okay? So not just measuring, also think about it graphically. Can we measure graphically? Is this a thing that we can do? Yes, we can, and it's called counting units, okay? So let's say that we have this, okay? And I'm just going to give it some values. All right. And we have a point at 3 over 3 up. So we have a point at 3, 3. Okay, and we're going to call this point A. And then we also have a point at negative 4, 3. 4. Okay, so this is negative 4. So let's say this is negative 4, 3. Okay, and let's call this point B. If we connect these two, now these two lines, now this line is parallel to the x-axis. So we can just count the number of spaces that it takes up, right? We have We have 1, 2, 3, 4, 5, 6, 7. All right, so we know that the distance between point B and point A is 7 units because we just counted. The reason why we were able to count is because our line segment right here was parallel to the x-axis. Now, can the same go for the y-axis? Let's see. I'm going to draw another graph. All right, so let's see. We have a line from 3, 5, let's call this point A, going all the way down to 3, -4. That's not really a very good spot for it. 3, -4. Okay, let's call this point B. So we have a line going from point A to point B. And this line is parallel to the y-axis. So this is a vertical line. We can do the exact same thing that we did with the last one. We can just count units because this line segment right here is parallel to the y-axis. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9. We counted 9 units as the length of AB. All right? So when the segment is parallel to the x-axis, we can count units. When the segment is parallel to the y-axis, you can also count units. Therefore, for vertical and horizontal lines, we can just count units. And that will give us the answer of the distance of a line. What about a diagonal, though? What if we have an xy plane right here, and we have a number that's going from point A to point B, but it's not parallel to either the y or the x-axis? Well, you can't count units, right? I mean, if you were to draw the squares, some of them are cut in half, some of them are cut in quarters, some of them are cut in this little part right here. You know, like it's really difficult to just eyeball it and count if the number is diagonal. So instead we need to do something else. If a line is vertical or horizontal, we can just count units. If a line is diagonal, we need to do something else. We need to use the distance formula. Okay? So to recap, if a line is parallel to the x or y axis, count units. If a line is diagonal, you must use the distance formula. The distance formula for diagonal lines. Diagonal, distance, maybe that'll help you remember it. Diagonal, distance. I don't know. That's just what you need to know. All right, so what is the distance formula? Well, the distance formula is, let's say you have 2 points. You have point A, then you have point B, okay? And your points are in the x and y form, as they always are, right? So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, well, where am I getting this x2, xy business from? Well, we have our first point here, so let's just call this x1 and y1. Then we have our second point here, and let's just call that x2, y2. Okay? So we're going to use the distance formula to find the distance of the segment that goes from A to B. I think it's just a little easier if we do this in the context of a real sample problem. So now that I've introduced the formula, let's apply it to a problem, okay? So in any distance formula problem, you are going to have a given. That is the information that is given to you, okay? So in this case, we have the point A, which is -3, 6, and then we have a point B, which is 2, -4. Now, you're definitely going to want to plot these points to begin because it gives you an idea of what you're exactly trying to find the distance of. Are you trying to find the distance of a diagonal line? Are you trying to find the distance of a vertical line or a horizontal line? It just kind of organizes your thoughts. Okay? All right, here we are. So our first point A, we have A at -3, 6. It's going to be right up here. -3, 6. Okay, and then we have B, which is 2, -4. So -4 down. Okay, now I'm going to want to connect my points and label them, so that way I know what I'm finding. All right, it looks like I'm finding the distance between point A and point B, and that forms a diagonal line. So I'm going to have to use the distance formula. So I'm going to assign A as x1, y1, and B as x2, y2. And that is literally just because A is the first coordinate that's given to me and B is the second coordinate that's given to me. I'm just going to make life easy and assign an x1, y1 to the first one and an x2, y2 to the second one. All right, so now I have the values that I'm going to plug into the distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? Now, I have these values all up here, right? x2 is right here. x1 is right here. y2 is right here. And then y1 is right here. All right, so I'm just doing easy substitution of my numbers. So I'm going to have, it's very important that you make sure the square root extends over the whole thing so that you don't get confused and just end up squaring part of it when you really had to square the whole thing, okay? So x2 is 2 minus x1 is -3. All right, and this all is squared, plus y2 is -4 minus y1, which is 6. That's squared as well. Now I'm going to simplify the things in my radical. I have 2 minus -3 gives me 2 plus 3, which gives me 5. And then that 5 is squared. So I have 25 plus -4 minus 6. That's -4. I'm taking away 6 more. I get -10. -10 squared is going to be 100 because a negative times a negative is a positive. So I have 25 plus 100 under my radical. I'm going to add them together. Take the square root. And the square root of 125 is 11.18. But I'm not done because I need to make sure that I let whoever is looking at this problem know that I know that 11.18 is measured in units. So I would answer the distance from A to B is 11.18 units. All right, and that's it for now.